So here we are at problem 3H from the limits worksheet. We're asked to find the limit as x approaches 2 of this particular rational function. And right away we actually see that there is in fact also a radical in there. Some of the previous techniques that we've tried is, for example, like the direct evaluation. And unfortunately here, it would not quite work out. We end up with actually that 0 over 0 indeterminate form. So a couple of other ideas though that should come to mind are like factoring. And also because of this radical, a lot of times what you're going to end up using is multiplying it by a conjugate. That's probably somewhere inside the problem. Not always, but a good majority of the time. Now, we end up then with the limit as x approaches 2 of, looks like we can factor out this top where we end up with x plus 4 times x minus 2 all over. I'm just going to go ahead and rewrite the bottom. We have the square root of x squared plus 5 minus x plus 1. Now, I know a lot of people, especially a lot of my former students, are kind of tempted to maybe distribute that negative in. In fact, it's actually to our benefit right now to kind of keep him where that is. And so not to actually distribute that negative in. Because the reason for that is it's actually, I think, going to help us in terms of setting up our conjugate. So what we're going to do is, because we want to try and get rid of this square root on the bottom, we're going to go ahead and multiply it by the conjugate. So we have the square root of x squared plus 5. And now, because it's showing a negative inside of the middle, we're actually, the conjugate of that would be multiplied by the positive in the middle. Then we also have our x plus 1. So because we've done that on the bottom, we also have to do that to the top. And again, the reason why this works is because essentially you're taking this entire rational function and multiplying it by, really this whole thing is just 1. In other words, what we're doing here is that foo that we've talked about in the past. So on top, right now, it's kind of tempting to want to just like multiply everything, but I kind of advise my students, just kind of take a step back, rewrite everything, and see, if anything will eventually just end up canceling out. In fact, factored form as you're doing limits is actually kind of nicer. So we end up then with the square root of x squared plus 5 plus x plus 1. So that entire top, haven't really distributed or foiled anything. On the bottom, this is where we actually see some more of like the math actually happening. Right now we have a binomial. It doesn't quite look like a binomial, but this entire thing is in fact a binomial because of that negative, multiplied by the second binomial. Now, when we just multiply the first piece, so first times first, we end up with, I'm not even actually going to do really kind of like any math. I'm just going to kind of rewrite what it means. So we have x squared plus 5 under that radical, and you're multiplying it by that square root of x squared plus 5. So essentially you're taking this piece and you're multiplying it by itself. Or in other words, what you're doing here is you're squaring him. For the second item, when you multiply the outers, you end up with the square root of x squared plus 5 times this x plus 1 term. And as a result, we end up then with x plus 1. The reason why we're doing that is it actually is considered to have a higher degree of 1 times the square root of this x squared plus 5 in the square root. I mean, the order doesn't matter too much, but I kind of want my students to get the habits of putting the square root second. Then we move on to the innards. So that's kind of the same thing where we have negative x plus 1 times that square root of x squared plus 5. And then finally, our last. And so we have a negative times a positive, so that just comes out to be a negative. And then we have x plus 1 times x plus 1. So really, all I'm just going to do is, since it's the same thing being multiplied by itself, is just rewrite it as x plus 1 being squared. All right, so because there is a lot of stuff on the board, let's go ahead and try and just kind of clean this up a little bit. So we still have the limit as x approaches 2 of x plus 4 times x minus 2 times square root of x squared plus 5 plus x plus 1. So really just rewriting the entire top. Haven't changed him at all yet. On the bottom, though, this again is where we're actually seeing a lot of that stuff happening. Now, if we have that square root of x squared plus 5, that entire thing is being raised to that second power. What happens there is that square root ends up actually canceling out with your squared term, leaving you with what was just underneath, that x squared plus 5. Now, the beautiful thing about multiplying by conjugates is we see that we have a positive x plus 1 times square root of x squared plus 5. And then we also have a negative x plus 1 times square root of x plus 5. And as a result, because those are really just opposites of one another, those just end up dropping out. The entire thing just cancels out. Then we have minus. I'm actually not even going to really do anything with the second part. We have x plus 1 quantity squared. At least not yet. I don't want to do tons of steps all at once. So now we've cleaned that up considerably, but let's clean it up even some more. So we still have the limit as x approaches 2 of x plus 4 times x minus 2 times the square root of x squared plus 5 plus x plus 1 all over this x squared plus 5 minus x plus 1. And really, because it's x plus 1 quantity squared, we can actually rewrite that as x squared plus 2x plus 1. In other words, all I've done is pretty much taken this guy and applied the squared. So there are some little rules, and hopefully you guys know those. But you could rewrite this FOIL, and you would end up. And so from here, if we actually went ahead and tried to do that direct evaluation, what would end up happening is you would still end up actually with that 0 over 0 indeterminate form, because you'd end up with a 0 because of this piece. And the bottom, when you plug in 2, you'd also get a 0. So unfortunately, the direct evaluation is still not going to quite work at this point. We have to try and kind of simplify things some more. So we still have the limit as x approaches 2 of x plus 4 times x minus 2 times the square root of x squared plus 5 plus x plus 1 all over x squared plus 5. And pretty much all I'm going to do is just go ahead and distribute in this negative to all of these terms. So we end up with a negative x squared minus 2x minus 1. So on top, we still have the exact same thing. We end up with x plus 4 times x minus 2 times the square root of x squared plus 5 plus x plus 1. Oops. Let's make this more of a parenthesis. I just noticed that should have just had an extra one. On the bottom, now we can go ahead and kind of combine like terms. Like we have x squared, and we are subtracting by another x squared. So those are gone. There's nothing really to be combined with this negative 2x, so we still have negative 2x on the bottom. And we also have 5 minus 1, so that's just negative 4. I'm sorry, positive 4. Now, one thing, though, that we can do, it doesn't really look like anything's kind of canceling out right now, but there is something that we can do on the bottom, and hopefully some of you guys can kind of maybe see that you would try at least factoring that. So let's see what happens when we try and factor him. So again, just rewriting the entire top, the bottom. What I'm actually going to try and do is pull out maybe a negative 2. So if I pull a negative 2 out, I'm left then with x minus 2. And the reason why I would pull out like a negative 2 as opposed to just like a positive 2 is the fact that now, hopefully you can see that these x minus 2's end up canceling. And really, that was kind of that main issue that we were having when we were trying to do that 0, or when we were trying to at least, use direct evaluation. We kept getting that 0 over 0 indeterminate form. It was directly because of these x minus 2's kind of playing a role. But now that they've canceled, we can actually go ahead now and try that direct evaluation. So we have the limit as x approaches 2 of x plus 4 times the square root of x squared plus 5 plus x plus 1 all over negative 2. Just kind of cleaning it up a little. All right, now let's go ahead and plug in this value. So we have 2 plus 4 times 2 squared plus 5 plus 2 plus 1 all over negative 2. In which case now we end up with 6 times the square root of 2 squared is just 4 plus 5 gives us 9. So we have the square root of 9 plus 2 plus 1 just gives us 3 all over negative 2. And so we end up then with 6 times. The square root of 9 is just 3 plus 3. Well, that's just 6 all over negative 2. And from here, you just end up with 36 over negative 2, which is the same thing as saying negative 18. So this would be that final limit that we should end up with. So again, that is problem number 3H.